Assalamualaikum and hi, it's me again. We are still in the estimation chapter, but this time we will explore on how to estimate the difference between the two unknown population proportions of success or failure denoted by pi1 minus pi2. Let's go. Before we go into details of the topic, let's first look at the topic's learning objectives. Similar to the other topics in this estimation chapter, we have three objectives here. At the end of this session, you should be able to achieve the first objective, that is to obtain a point estimate for the difference between two population proportions denoted by pi1 minus pi2. You should also be able to achieve the second objective, that is to construct a confidence interval for pi1 minus pi2. And finally, you should be able to achieve the third objective, that is to interpret the constructed confidence interval for pi1 minus pi2. Let's see how we are going to achieve the first objective in the next slide. Suppose we have two unknown parameters, which are the population proportions of success denoted by pi1 and pi2 respectively. We know that the point estimate for pi1 is the sample proportion 1 denoted by p1, and similarly the point estimate for pi2 is p2, which is the sample proportion 2. The question now is, what is the point estimate for the difference between the unknown population proportions pi1 minus pi2, where pi1 minus pi2 is the parameter of interest in this topic? The answer to this question is quite simple. The point estimate for pi1 minus pi2 is the difference between the sample proportions calculated or obtained from sample data denoted by p1 minus p2. Please refer to example 3.4 from Statistics for Engineers textbook, pages 72 and 73, for an example on finding the point estimate for pi1 minus pi2. Here we have the question. In Teguh Plastic Factory, plastic parts are found using two different injection molding machines A and B. Two random samples, each of size 200, are chosen and 5 defective parts are found in the sample from machine A, whereas 6 defective parts are found in the sample from machine B. The question we want to address here is, find the point estimate of the difference between the true population proportions of defective parts from machine A and B. Before answering the question, as usual, recognize or identify the information given in the question and write the information using the correct notation. Suppose we denote machine A as 1 and machine B as 2. Now, looking at the information in the question, each of the sample sizes is 200. This value 200 refers to N1 and N2. Next, we also know that the number of defective parts are 5 and 6, denoting the number of defective parts from machine A and B respectively. So we can denote these two values as x1 and x2. Hence, we can obtain the sample proportion values P1 and P2, which are the point estimates for pi1 and pi2 respectively, by dividing the number of defective parts by the corresponding sample size. Here, P1 is 5/200, which is equal to 0.025, and P2 is 6/200, which is equal to 0.03. Do you follow me? Good. Hence, the point estimate for the difference between the two unknown population proportions of defective parts from the two machines, that is, the estimate of pi1 minus pi2, written as pi hat 1 minus pi hat 2, is P1 minus P2 given by 0.025 minus 0.03, which is negative 0.005. Do you think this negative value acceptable? The answer is yes. It gives us an indication that on average, the proportion of defective parts formed by injection molding machine B is expected to be larger than that formed by machine A. Now, let us explore on how to construct a confidence interval for pi1 minus pi2. Similar to the previous concept on constructing a confidence interval for mu1 minus mu2, we can recall a sampling distribution of a difference between two proportions, P1 minus P2, from Chapter 2, which is normally distributed with mean pi1 minus pi2 and variance pi1 1 minus pi1 over n1 plus pi2 times 1 minus pi2 over n2. The standardized random variable for P1 minus P2, denoted by Z, is then given by this expression, where Z is the sampling random variable P1 minus P2 minus its mean pi1 minus pi2 divided by its standard error, which is the standard deviation of P1 minus P2. The sampling distribution of a difference between two proportions P1 minus P2 and its standardized random variable Z are both available in the statistical table booklet, page 3. Now, let pi1 minus pi2 in the Z formula be our parameter of interest. Rearrange the Z formula will give us the following expression. By borrowing this expression, we can then construct a confidence interval for pi1 minus pi2, which is explained further in the next slide. From the previous slide, we already saw how we get this expression from the standardized normal random variable defined for a difference between sampling proportions P1 minus P2. By modifying this expression, we can then construct a two-sided confidence interval for the difference between the unknown population proportions of successes or failures given by this expression below. Small p1 minus small p2 plus minus z-score at alpha over 2 multiplied by the square root of p1 1 minus p1 over n1 plus p2 times 1 minus p2 over n2. Notice here that the sampling random variable p1 minus p2 in the first expression now changes to a small p1 minus p2, which is the point estimate value for a difference between two unknown population proportions, pi1 minus pi2. The minus sign now changes to a plus and minus sign, since we have a two-sided confidence interval based on a Z distribution. The Z random variable in the first expression now changes to a Z score and alpha over 2, and the notations pi1 and pi2 are replaced by P1 and P2 respectively. Please note that P1 and P2 are estimated value for pi1 and pi2 respectively, and we only deal with large sample sizes where N1 and N2 are at least 30, and we only have one case in constructing the confidence interval for pi1 minus pi2 in this topic. Refer to example 3.4 again from pages 72 and 73 of the textbook. This time, we aim at constructing a 99% confidence interval for the difference between the unknown true population proportions of defective parts molded by machine A and B, that is, a 99% confidence interval for pi1 minus pi2. You can also use pi A minus pi B if you like. It's just a matter of notation for ease of writing the mathematical formula. This time, the proportions we are interested in are the proportions of failures instead of proportions of successes. Again, before answering the question, you should be able to identify or recognize the information provided in the question and write the information using standard and correct notations. For example, we have N1 and N2 equal to 200, X1 equal to 5, and X2 equal to 6, where X1 and X2 are the number of defective parts from machine A and B respectively. As in the previous example on finding the point estimate for pi1 minus pi2, we have all the information written down like this. Therefore, the 99% confidence interval for the unknown true population proportions of defective parts molded by machine A and B, that is, the 99% confidence interval for pi1 minus pi2, is given by this expression. Remember, we only use a Z-score in the formula, not a T-score, where the Z-score is Z0.005 given by 2.5758 from Table 4 of Statistical Table Booklet, page 34. Substituting all required values in the formula, we then get this answer. The confidence interval for pi1 minus pi2 is negative 0.0471 and 0.0371. You can also construct the confidence interval for pi2 minus pi1, but be sure that you will start the formula with the point estimate for pi2 minus pi1, which is p2 minus p1, not p1 minus p2. So please be consistent in your steps. Either using p1 minus p2 or p2 minus p1 in the formula, you will get the same inference or interpretation. In this example, the lower limit indicates a negative difference, whereas the upper limit indicates a positive difference. What can you infer from this answer then? You can say that with a 99% confidence, it is expected that there is no difference between the proportions of defective parts produced by the two machines based on the sample data. Why is that so? A possible reason is that because the confidence interval does contain a value of 0, which indicates no difference. What about the margin of error in this question? Here, the margin of error is the multiplication of z-score and the estimated standard error of the sampling random variable P1 minus P2. The margin of error is the multiplication of z0.005 and the estimated standard error of the sampling random variable P1 minus P2, which is given by the square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. You can check the answer and see if you get 0.0421 or 4.21%. Do you get the answer? Hope you can do that on your own and see whether you get the same answer. What are we saying based on this answer? Here we are saying that the 99% confidence interval for pi1 minus pi2 is the point estimate P1 minus P2 plus minus the margin of error of about 4.21%, which results in the answer negative 0.0471 and 0.0371. Look at another example. Please refer to task 3.9, page 73 in Statistics for Engineers textbook. A survey is conducted by Independent Engineering Education Research Unit, who found that among teenagers aged 17 to 19, 20% of schoolgirls and 25% of schoolboys wanted to study in an engineering discipline. Suppose that these percentages are based on random samples of 501 schoolgirls and 500 schoolboys. Determine a 90% confidence interval for the difference between the proportions of all schoolgirls and all schoolboys who like to study an engineering discipline. From this task question, the focus is on constructing a confidence interval, and the parameter of interest is the difference between the unknown proportions of successes pi1 minus pi2, where the proportion of success here refers to the proportion of teenagers who want to study in an engineering discipline. Again, you may want to extract the information first, which can be used later to solve the question. If you use 1 to represent girls and 2 to represent boys, then you have 501 and 500 to be the sample sizes N1 and N2 respectively, whereas 20% or 0.2 and 25% or 0.25 are the sample proportions P1 and P2 respectively. Please remember that we only have one case in constructing a confidence interval for pi1 minus pi2, that is to use a z-score in the confidence interval formula. For this question, alpha is 10%, so we'll use z0.05, which is equal to 1.6449 from the table. Let's look at the answer in the next page. We continue with the solution for task 3.9 in this slide. Having extracted all the information needed for constructing the confidence interval, now you can substitute the relevant values in the confidence interval accordingly. Therefore, the 90% confidence interval for pi1 minus pi2, which is the difference between the population proportions of girls and boys who want to study in an engineering discipline, is given as follows. By substituting all the relevant information in the confidence interval formula, the answer is then given by negative 0.0933 and negative 0.0067, or simply negative 9.33% and negative 0.67%. If you were to construct the 90% confidence interval for pi2 minus pi1 instead, then you will get the answer to be 0.0067 and 0.0933, or simply 0.67% and 9.33%. Now, suppose you have another extra question. Is there any difference between pi1 and pi2 with a 90% confidence? Verify your answer. How do you answer this question? If you observe the 90% confidence interval, you should notice that both limits, the lower and upper limits of the confidence interval, are negative in this case. Or if you consider pi2 minus pi1, both limits, the lower and the upper limits, are positive. So the answer to this extra question is yes. How to verify? You can say that the 90% confidence interval does not contain zero, which indicates that a difference between the proportions of girls and boys who want to study in an engineering discipline is expected to exist with a 90% confidence. In short, for any confidence interval for pi1 minus pi2, we can consider a zero value to be a reference value or an indicator to decide whether the two population proportions are expected to be different or not with a certain degree of confidence. That is, if the confidence interval contains zero, then no difference is expected to exist between pi1 and pi2. On the other hand, if the confidence interval does not contain zero like in this question, then a difference is expected to exist with a certain degree of confidence. Before ending this session, let us do a checklist on the achievement of this topic's learning objectives. After watching this video and learning the techniques of estimating the difference between the unknown population proportions denoted by pi1 minus pi2, are you now able to calculate the point estimate for pi1 minus pi2, which is the first learning objective of this topic? Please recall that the point estimate for pi1 minus pi2 is simply p1 minus p2, which is the difference between the two sample proportions that you can obtain or calculate from sample data. What about the attainment of the second learning objective? Are you now able to construct a confidence interval for pi1 minus pi2? Remember, we only have one case in constructing the confidence interval for pi1 minus pi2, where we only need to use a z-score in the confidence interval formula and both sample sizes are assumed to be large. Finally, are you now able to interpret the constructed confidence interval for pi1 minus pi2? Please have a look and try out more questions on this topic to get a good grip on the topic. Do not hesitate to contact me via email or WhatsApp if you have any queries related to this topic. Until then, Assalamualaikum and thank you for watching.